I'm a scientific researcher of Institute of Organic Synthesis and Chemistry of Kazakhstan Republic. Kazakhstan is a state in the Eurasia Center. Also, I'm a student of Buketov Karaganda University. And the theme of our poster presentation is fabrication of iron copper catalysts on the basis of copper ferrite. The main purpose of our presentation is to create effective iron copper bimetallic catalysts on the basis of copper ferrite for their application in electrocatalytic hydrogenation of organic compounds. Also, we investigated the ability of copper ferrite to thermal and electrochemical reduction with the formation of iron copper composites and the influence of polymer additions on the processes. As is known in catalysts, ferrites are transition metals and their mixed compositions have been successfully applied. Moreover, their magnetic properties allow too easy to remove them from the reaction system and repeatedly use them practically without loss of catalytic activity. First, I will begin with experimental section of my poster. The copper ferrite samples were prepared by co-precipitation method using copper and iron salts without and with the addition of polyvinyl alcohol as polymer stabilizers. The fabricated samples were heat treated at 500, 700, and 900 degrees Celsius 2 hours. Here at this poster, you can see the general scheme for preparation of copper ferrite samples. Next, the heat-treated copper ferrite samples were deposited on the cathode surface in the electrochemical cell with the aim to reduce them. The scheme of the electrochemical cell is shown on figure 2. Now, we will move to the section results and discussion of this poster. Okay. The figure 3 shows the X-ray patterns of copper ferrite samples after heat treatment and electrochemical reduction. According to the X-ray patterns of copper ferrite samples after heat treatment, there are only copper copper oxide crystalline phases in their constitutions. However, after electrochemical experiments, the reduction of iron and copper cations occur, and the iron and copper metals with different ratios are formed. Let's look now at figure 4, namely X-ray patterns of copper ferrite samples prepared with the addition of polyvinyl alcohol. According to figure 4, after heat treatment, there are the crystalline phases of copper ferrite, iron oxide, as well as reduced copper and iron with different ratios. The electrochemical reduction of these samples leads to additional reduction of metal cations. This leads to the next point, which is the thermal treatment of copper ferrite sample synthesized in the presence of the polymer is accompanied by the metal reduction. This process is facilitated by polyvinyl alcohol decomposition products absorbed on the surface of precipitated metals. The table shows results of electrocatalytic hydrogenation of organic compounds on the iron copper composites as electrocatalysts. It can be seen from the table that the hydrogenation of nitrobenzoic acid on the kappa cathode without catalysts occurs with a rate 3.7 milliliters of hydrogen per minute, and condensation degree is about 64%. It should be noted that the hydrogenation of this acid using copper ferrite samples significantly increases the rate and condensation degree of these organic compounds. In the case of the electrohydrogenation of acetophenone using copper samples prepared with salt and with polymer addition, the rate and condensation degree also came up compared its electrochemical reduction on the copper cathode. The main conclusions are given in the end of the poster. Firstly, copper ferrite samples were prepared by co-precipitation method without and with the addition of polyvinyl alcohol. Secondly, the iron copper catalysts were obtained during thermal and electrochemical reduction of copper ferrite samples. Thirdly, it was established that all iron copper composites have good catalytic activity in the electrohydrogenation reaction of organic compounds. We are sure that the as-prepared iron copper bimetal composites can be also used as catalysts in various electrocatalytic and catalytic processes of organic chemistry.